In this video, we will be adding a falling boulder which respawns at a random X position at the top of the screen. So the first thing we want to do is add our boulder to the scene. I'll just switch this tab so I can see the game view simultaneously with my scene view. And I right click in the hierarchy. I add a 2D object, sprites, and then I would add a circle to represent our boulder. I'll just call it boulder out here in the hierarchy. And to differentiate between the different objects, I'll just give it a contrast color like a green, and I'll move it up here. So it should start around here in the game. Now, when I showed you the gameplay, it may have looked like boulders just came falling down one after another. But what actually happened, this is kind of a performance trick. We just used the same boulder over and over again, so we didn't have to instantiate new objects. So what actually happened is the boulder falls from here, it falls down, and you can see this white square, this white outline. This is what we can see in the game. So if I move just inside the white square, you can see the boulder here. If I move it outside, you can't see it anymore. And what actually happened is when it exited the boundary and was not visible to the player, what actually happened was that I respawned it by resetting its Y position to around here, I believe, and I gave it a random X position between the left and the right screen boundary. So this is what we want to happen, but let's start out simple by just making it fall down. For this, we would need to add some behavior to a boulder. We can do this best way by adding a script. So we can click add component. Then I can just type whatever name I want from a script. I will type boulder behavior. As you can see, it's just the new script as it can't find anything called boulder behavior. I will create an add, and then by itself, it actually registers, oh, we have a folder called scripts. Maybe I should put it in here. I'll save it right here in the scripts folder. We will be needing the start and the update method, so I'll keep these for now, but I will delete the comments. Now, to make the boulder fall down towards the bottom of the screen, what we first want to do is create a variable which can represent the speed of the boulder. And this is actually the first challenge of the video for you. I would like you to add a variable that can represent the speed of our boulder, and we need to be able to change this variable outside in the Unity editor. If you're not really clear on how to do this, go check out my last video where we added player movement. And if you followed the last video, you might have your player controller script still in your scripts folder. You can go have a look at that as well. But now I will give you a quick sec to pause the video so you can try this out for yourself, and then you can follow my solution afterwards. So if we go into a player controller script, you can see here we created a private float called move speed, and we used serialized field to keep it private, but still be able to change it in the Unity editor. We will do the same again here. We will, in square brackets, type serialized field, and then I will create a private float. I will call this boulder speed, so I can differentiate easier between the different kind of speeds we've created. And I'll just set this to 5F, same as our player. Now that we have the speed, we can actually make it fall down the screen. So last video, I stated that fixed update, another Unity built-in method, is best for handling physics. That is when we use the rigid body. We want this downwards movement to be constant as well, but we're not using physics in the same way as we're not adding a rigid body to our boulder component. So that's why we can just do this in update. So for instance, if I wanted our boulder to move to the right, then we have this component, the transform of the game object. I could access the transform just by typing transform, the transform of the game object, so our boulder, and we can use the built-in transform method called translate. Moves the transform along its X, Y, and Z axis. And then it gets a bit more confusing from there on. But just remember the first part, moves the transform. So we move the object. And we do this by using parentheses. It says it needs a vector 3, but we can also use a vector 2. So we can, for instance, create a new vector 2. And then we need the X and the Y axis. If I wanted to make it move to the right, then I could tap 1 to make it move 1 pixel to the right each frame. And to get it to move to the right, I would like to keep the Y axis as 0, as I don't want to move it up or down. And then when we exit the parentheses, we can multiply this by the speed of our boulder, and then multiply this by time dot delta time. And again, a good performance tip, multiply the floats together first. So we can do it like this, then we multiply the two floats together first, save the script, and then in the Unity editor, when we play our game, as you can see, it moves to the right, and it just continues outwards forever and ever. That's actually shorthand of writing this. Instead of writing new vector or creating a new vector variable, I could actually just write vector 2 and then dot for the extension methods, and it has a right. So a shorthand for writing vector 2 1.0, which is actually the value we wrote before. So if I type vector2.right, save the script again, then I can start our game, and it has exactly the same behavior, but vector2.write is a bit easier than reading new vector2 parentheses 1.0 parentheses end. So now the next challenge for you, instead of making our boulder move to the right, try to move it downwards. I will give you a quick sec to pause the video so you can try this out for yourself, and then you can follow my solution afterwards. So this is a fairly small change. We could create a new vector2 and just set it to 0 on the x-axis as we just want to move it downwards, and then -1 on the y-axis. Now this would work, but as we saw before, it can be more readable to just use vector2 dot the direction you want to move towards. So it had right, but it also has left, up, and the thing we need, down. So as you can see, this is shorthand for writing vector2, 0, point, -1. Go back into the Unity editor. When we play, it moves downwards. So now we have two ways of moving. We have the rigid body, which we use to move our player, and we have the transform, which we use to move the boulder. So there's two different ways of making objects move. Just to show you, there are multiple ways to make objects move in the game. Now to reiterate what we wanted, when we play the game right now, it just continues and goes down and down and down until we stop the game. So now let's go to the next step. What we want is that when it exits the bottom boundary, it respawns up top. So how would we do that? Well, we need to set some sort of boundary for our screen, and that would be a position. And a position in Unity or transform position is normally represented by a float. So we could create variables up here for the boundaries of a screen. We could create a private float called screen top. We could create one as well for the screen bottom. That's just why we added. Create one for the left side of the screen and one for the right. So now we have the top, the bottom, the left side, and the right side of our screen. Well, how do we set these bounds to actually be active in our game? Well, what we could do to define our boundaries is find the exact value of the boundary. So if we move it all the way downwards, let's say we wanted the bottom boundary of the screen to be here, we could set it to -5.35 on the y-axis, but this would not be very dynamic. Let's say you made your game view bigger. Let's say you ported this to a mobile phone. Well, then these values would change. The screen wouldn't be as wide. It might not be as tall as when you play it on a PC. So therefore, we will use dynamic values instead of hard-coded values. So now we need to define what our boundaries are, no matter the screen size. To do this, we can access this main camera and then access its field of view, so what it sees as the game screen. First, we will access this camera by typing camera. We will just call it main camera equal to camera.main. So now we've accessed our main camera of the scene. So the object you see out here in the hierarchy, main camera. And you can also see this is actually tagged as the main camera. Now we will need some kind of height and some kind of width for our camera. So I will create the float cam height, and this is equal to main camera dot orthographic size. This can be a bit confusing, but I will explain this in a minute. Now we will need to create our cam width, and for this I create a new variable called cam width, and I will set it to cam height times the main camera dot aspect. So now what we've essentially done, using these three variables, we can see how far there is from the camera to the boundary of the screen. And where is our camera placed? Well, it is placed dead center in the middle of the game. Let's just set the vertical bounds first. So to set the vertical bounds, we can set the screen top, so the top edge of our screen, to our main camera dot transform dot position dot y, because remember right now we want the vertical angle, so up and down. That's why we're using the y-axis, and we will add our cam height to this. So we're accessing the y-axis of our camera, this transform dot position right in the middle of our game view, and we're adding the height of the cam to set the top screen bound. I realize this part can be very confusing, but don't worry, you'll get it at some point. Just think of this for now as we're finding our camera, we're finding the height and the width, so the field of view for the camera, and then we're accessing the transform of our camera, which is in the middle. And to set the top of the screen, we would take the position of the camera and we will add the cam height. So now for the next challenge, try to set our screen bottom. So find the bottom boundary of the screen. Again, this part can be very confusing, so don't feel bad at all if you can't complete this challenge, but give it a good go. Pause the video now, and I will see you in a bit to show you my solution. So to set the bottom boundary of our screen, we will again access our main camera and the transform that position on the y-axis, because now we're going downwards. So we're still on the vertical bounce. And instead of adding the cam height, we will subtract the cam height. So now we have the top and the bottom boundaries of a screen. Now we will create the horizontal bounce being the left and the right side of the screen respectively. So let's start by adding the screen left. Again, we will access our main camera .transform.position, but now we're going horizontally and not vertically. So not Y, but X. And remember, now we're going to the left. So this, if I'm moving this to the left, see the X-axis, it's negative. So that's why we will subtract the cam width. Next challenge for you, try to set the right boundary of the screen. If this is too challenging for you, don't worry, it is a very difficult topic right now, so don't feel bad at all. But just try to look at this, how we set the screen top and the screen bottom compared to each other. Then look at this and think of it in the same pattern as how we set the vertical bounce. And then try to set the right side of the screen. I'll give you a quick second to pause the video and then come back to see my solution. So to set the right side of the screen, we will access our variable screen right. And once again, we will access the main camera .transform.position.x. And with this time, we will add our cam width. So now we actually have our screen boundaries. So now we can go down to our update method. And here we can check for the boulder's position. And to check, well, is the boulder underneath the screen? Then we want it to be at the top of the screen once again. So we can check if the transform.position.y, we need it to be negative. So if it is less than the screen bottom boundary, then we would like to set our transform.position of the boulder to a new vector 2. Let's just set it to 0 on the x-axis to make it spawn in the middle, and then screen top. Let's save the script, hop back into the Unity editor. Let's try to play this. So when it goes outside the screen bottom, it respawns at the top. That was the second step. Now we got it to move and to respawn. Now for the next and final step, we would like it to spawn randomly at the x-axis between the left and the right boundary. So how can we find this random x position? Well, we can create a new float and call it random x. And then we can set it equal to a method built into Unity called random.range. And as you can see, we need a min and a max. And inclusive just means that the number you set is included in the range. Let's just say the min was inclusive and the max was exclusive. Then if you set it to 0 and 5, then it will be between 0 and 4. As you can see here, when we're using ints, then it's inclusive and exclusive. But we are using floats. So therefore, both the min and the max are inclusive. And what do we want the range to be? Well, we want the min, so the lowest number on the x-axis, to be the screen left. And what do we want the max to be? You might already have figured this out. We want it to be the screen right. So now we have our random x value. Now the next challenge for you is to change our transform.position, so where we spawn the boulder when it exits the bottom of the screen, to be at our random x position instead of just the middle of the screen. I'll give you a quick sec to pause the video and try this out for yourself, and then you can come back and see my solution. Well, actually, instead of just respawning it at 0, we would like to spawn it at our random x position. So if we save the script, jumping into Unity and start the game, as you can see now, when it respawns at a random x position between the left and the right side of the screen. Now, one final thing I would like to do before we end this video is that the update method is kind of looking a bit messy. We're doing a lot of things in the update method. We're moving the boulder and we're finding the random x value and we are respawning the boulder. So what I would actually like to do is that I highlight this part of the code and I will hold down my left control and press dot. And as you can see, this gives a quick action called extract method. I will click this. And what are we doing in this method? Well, we're moving the boulder. So we'll just call it move boulder. And this creates a new method and it automatically writes it in the update as well. So it's still called in our update method. And this part of the update loop is calculating our random x and respawning the boulder. I would like to extract this in a method as well. I can use the control dot, or I can just cut it with control X And then I can create my own method, private void. Let's just call it respawn boulder. And I can just paste it in here in the method body. And then I can call it up here just to show you there's multiple ways of doing it. But by far the quickest is of course just to extract the method using the control dot extension. Now the last challenge of the video for you. This is a long start method as well. So for this challenge, I would like you to extract this code into its own method and then call it at the start method instead of just writing it directly in start. Pause the video now and then come back to see my solution. Well, just like we did before, let's just highlight all of this, hold down left control, press the dot. It gives us this extension where we can extract the method. I will just call it calculate boundaries. Actually, let's rename this. I'll just highlight it again, hold down control and press R twice. I'll name it calculate screen boundaries. I always like to be very explicit with my naming. So boundaries could be boundaries for anything. I would like to calculate the screen boundaries. So I'll change the name to that. And I would actually like it to be underneath the update loop. So I'll just cut it and then place it here. This is just my programming OCD. I like to have the start and the update, so the build methods first, and then the methods I've created on my own in the order that they are called. So we have calculate screen boundaries, move boulder, respawn boulder, and these are in the same order. So now we have our boulder spawning at the top when it reaches the bottom of the screen, and it's spawning at a random X position. In the next video, we will be adding collision to the boulder, so our player actually has an incentive for avoiding the boulder. If this video helped you out, please consider leaving a like and a comment, as this helps me out massively. And remember to subscribe for more content. Thank you for watching.